in this case, we're just going to ignore the notes. In your case, the notes might be extremely useful as far as which data run you're going, what your objective was when you ran the sample, etc.
I'm just going to do this, just for the heck of it. And what was that bag?
C.
Big C.
Just for the heck of it. Okay.
And let's. This is not relevant.
Okay, I wasn't sure.
And we're going to hit OK. And in this case, it's going to ask you where you want to save it.
Okay.
Now, this is where we will put your data management skills to the test. So you're going to have the curse of so much data and where to put it and how to organize it. And in this case,
That I can do.
we're going to do a folder designated for 4x 300 micron samples.
Yep.
So we have 4x 300 micron under the high-tech folder.
Right.
And the list file, you can let it be the serial number if you want. Those are automatically generated if that's the most helpful way for you to track your data over time.
I like to do
Or-
everything with year, month, day,
Yep.
hour, minute, second.
Exactly.
Yeah.
So in this case, it's HTB1
Right.
dash
And it's 1609.
so
What is today?
0907
Yeah.
16 as the
Do
serial.
16 first, because that way it'll always come up first. So 160906,
So
right?
we can even do it
Yeah.
160906.
Yeah, and then you've got
And-
1154,
1154.
and that's all right, because you're not going to do it any more than a minute apart.
Great. So, however you want to
Right.
differentiate your data runs,
Yeah.
and we're going to save that list file name under high-tech under
Yep.
4x 300.
Okay.
Exactly. Cool. Oh, as soon as you do that, it starts.
Mm-hmm.
Okay.
In many cases, now, look what we've already done wrong. See how it's calibrated the background, but it's calibrated the background without any sample actually in there. And we don't have any particles, and then all of a sudden we have particles.
Right.
So the first thing we did wrong was we didn't aspirate the sample and bring it into the sample area, into the flow cell.
But
the
all
second
that
thing
means is your first grouping is going to be nothing. So you can get rid of those.
we have a clean flow cell. So inevitably you're going to have your flow cell in there and like one little guy stuck to the side of it, and you can still use that flow cell, but you're going to have to make sure that that has been imaged as part of the background.
Okay.
And so we can do that in auto image mode, say this clogs. Say, okay, you know what, like I'm having a problem with, oops, these pass through so fast at 4x.
Yeah, really.
So let's show all and let's just check it out. See what we have at 4x. So I'm going to sort the data by size. Really little guys up front. And I can either hit this up arrow in reverse,
Yeah.
or I can hit this arrow with the end point and go to the last page. Doesn't matter. So we have these, what are these filaments?
That's what I'm seeing in there. I just, those, and I saw in the microscope these groupings here, which I looked into everything I could and looked like cyanobacteria, but I really don't know what they are. All of these, and they're very similar.
So these are huge, these filaments. So the length of this guy, we need to bring length into the field of view here. So
Could any of these be inert or like detritus or compounds or anything like that?
sure,
Yeah.
yeah.
I mean, that doesn't That's what I wonder.
Could
A
be,
Yeah.
lot.
could be what?
Compounds or just inert, material and that's not really even biologic.
But the question is, how do we get in there? Because a trailer, we get perfectly isolated and super sterile samples from the university. And this would be helpful that when we first get the samples, to put them through here, make sure there's nothing in there.
Mm-hmm.
And then as we're growing them up in the trailer,
Right.
getting ready to inoculate the large tanks, to see if any impurities or invasives,
I would be surprised if your cultures prior to introduction into your tanks really are pure.
Mm-hmm.
Mm.
It's tough to.
I would never think it was.
Mm-hmm. Yeah,